Okay, so let's go ahead and summarize then what we found out from our Frito-Lay video and our soup example. Okay, so what did the Frito-Lay video help us understand? Okay, good. Doesn't matter the size of the sample. How about also, remember they talked about understanding the characteristics of the entire load of potatoes, the entire population, based on a small sample. Okay, so that I think is probably the main idea from our Frito-Lay. You can get characteristics of the entire population, which in the case of the Frito-Lay example, what was the entire population? Good, 45,000 pounds of potatoes that were on the truck by sampling randomly. They did sample random. They correctly sampled. That's the key, and that's what we're going to learn about, how to correctly sample by sampling randomly. Okay, period. By just sampling randomly. Okay? So they took 150 pounds, then they looked at it. They then could tell that the whole 45,000 pounds was good or bad. Okay. So then our soup size, though, really had more to, or our soup sample really had more to do with the size. For example, it said that with the small pot of soup, you use a teaspoon. But with the bigger pot of soup, did we need an entire ladle? No. So your teaspoon, your sample size works for populations no matter what size the population is. Does that make sense? Okay. So, correct. Your sample size, and it has to be correct, a toothpick is too small. And then, you know, like if you sampled 75% of it, then that might be too big. We're actually going to get into the mathematical part of exactly how much and percentages-wise later in this year. But for now, just knowing that the sample size really doesn't matter is all that you need to know. The sample size, if large enough, we'll say that. And we'll get into that because the toothpick in the soup didn't work. If large enough, doesn't matter. It could be a spoonful in a small and a spoonful in a big vat of soup, and it's still going to be good. Okay. All right. Now this next part is really used, and we're not doing equations really yet, and we're not doing formulas yet, but it is in this chapter. And so we're going to take the time right now to point out the differences between the way that you notate or write a sample statistic, and a statistic is what is found from your sample, so write that there, and a parameter is something that you generalize for the entire population. Now, the interesting thing, now, is it realistic? Say you worked at Healthy Choice and you created this soup, and so you took a teaspoon of this big old vat of soup and you took it to the lab to get its saltiness and its fat content and its calories and all that kind of stuff. Okay. Is it reasonable to think that you're going to take the entire vat or the entire population of the soup to the lab to analyze? No. So we typically do not perform a census, which is the taking care of all of the, or sampling or analyzing the entire population. Usually we do not analyze the entire population. Usually we just analyze a sample and we get a statistic. So statistics are done with Latin letters. And so in our formulas, we'll come across this once we get into the next unit. X bar would represent an average. No, not yet. We're not to the central limit theorem yet. What we're going to, it's kind of more heading towards, we're going to get into normal, the normal curve and stuff. Yes. So X bar, and then standard deviation, which you don't really know yet because we haven't done that chapter yet, but it is notated by just a plain S. Okay. And then there are others in the book on page 276, but we haven't really gotten into formulas and the mathy stuff yet. We're going to after this unit. Now, population, however, uses Greek letters. And see, to me, this is really strange because we never can examine the whole population. So can we ever really legally or legitimately use a Greek letter? Can we ever say that we examined the whole population? No, but as we work through this year, we're going to try to prove over and over and over that these statistics we gathered from our sample can just as well represent the entire population. Okay, so the thing that would represent the mean is this Greek letter mu. Kind of looks like a cursive U, but it's called mu. And then for standard deviation, it's a Greek letter sigma. It kind of looks like an O with a cursive lowercase o. That is a lowercase sigma. Okay, but you just have to realize that there is a difference between sample statistics, the data you got from your sample, and the parameter that defines the entire population. We're hoping we can prove that these sample statistics are going to be the same as our population. That's what we're going to work on this whole year. Okay, now let's talk about various ways that we can sample correctly. Okay. If we learn how to sample correctly, then could we, like the Frito-Lay example, say that represents the entire population of the whole thing? Okay, that's what we hope. All right. So ideas of what simple random sample would represent. And these then are getting into your vocabulary. So if we went through your vocabulary cards, we'd start seeing these showing up, and it's very vocabulary driven, this chapter. Yes?
Okay, with potatoes, did we know how to collect it? What if that, I mean, by chance that fantasy was all, or like, could have been all of the good ones, and then more bad, for example. So, wouldn't bigger samples help? Like, more, like, maybe like 150 pounds can be sampled by this group and 150 years, that like more that you can get out of the population.
Well, the idea is that if those potatoes are really in there randomly, then all of those bad potatoes are sprinkled throughout the whole, they are mixed up, and they are sprinkled. So when you get only the 150 pounds on top, then you wouldn't get a significantly more bad ones or just all the good ones. And so that's the point, is that they have to, they have to assume and make that assumption. And I guess over truckloads, maybe over truckloads, they lose out in some of them. Maybe over truckloads and truckloads and truckloads of potatoes, their sample wasn't as good, or their whole truckload wasn't as good as they thought it was. Okay, but then there's going to be other truckloads that it ends up being a whole lot better than even the sample was, and they took it. And so averages of averages over time are going to average out, and that's kind of what even the central limit theorem gets to in sampling distributions in Chapter 18 later. Averages of averages, okay.
Because I was thinking, like, when the smaller the sample, and that was they send out that.
Well, I think that like type 2 error would isn't referring to like a number of things. I don't know. I don't think I can correctly answer that right now. So, sorry. Okay. So, but let's look at different ways that you can organize, you can collect your sample so that you feel as though it can correctly represent the entire population. Okay? So this first one is a simple random sample. Okay, so simple random sample. What do you think that means? Simple random sample. we could look in our vocabulary cards. If you have your cards, you might want to pull them out because we're following along these. Now we're getting into a lot of vocabulary, and Chapter 13 is even more. But we're in Chapter 12 right now. Simple random sample. Every unit has an equal chance of being selected, and all the combinations are subjects are possible. So let's pretend, let's make real examples here, and let's use the Aledo High School as our population. So let's come up with some examples here. We don't need to write definitions because you have those on your cards. We're going to come up with examples to help you remember what these words mean. So let's pretend that for these examples, we're going to say that our population is all the students at AHS. Okay? So a simple random sample. How could we collect a simple random sample from all the students at AHS? They're all equally likely to being picked. How could we do that? What do you think, Jake? Perfect. Take all their student ID numbers and randomly generate ID numbers. Okay, good. So assign student numbers. You know, take the roster of the high school, give them all a number, and then generate random numbers Okay, very good. Generally, or randomly select numbers. Now, say we're having a poll about where you get to sit in the pep rally. Well, don't you think that might be meaningful to 9th graders versus 10th graders versus 11th graders versus seniors? Well, it could be that we decide we want to make sure that we get an equal representation of freshmen, sophomores, juniors, and seniors. If that's the case, then what we would do is stratify our sample, or stratify our group first, our population, into strata. So what you want to do first is group into, how do you think I should group them? How should I group our school? Into what? Good, into classes. So like, as not to confuse it with English and math and all that kind of stuff, I'm going to say 9th, 10th, 11th, and 12th. Okay, so let's group it into freshmen, sophomore, juniors, and seniors. And then randomly select from within those classes. From within each group. So I might say, okay, I want to pick 4 people from each class. And so I pick 4 freshmen, 4 sophomores, 4 juniors, 4 seniors. And then they're on a committee and they have a discussion or whatever, I don't know. Okay. All right, now cluster sampling. Here's an example of why you might cluster sample. Say I want to, and I think this might be the way it shows you an example in your textbook. And I do want to remind you that us going through these notes is not to replace you reading the text, because the text will hit some vocabulary and some other things more in depth. I just think you'll have a better reading experience and you'll grasp more and it'll sink and stick more if you kind of know where you're headed first when you go start reading. That's the way I am anyway. Okay, so cluster sampling. You might do cluster sampling if, say, you wanted to know the average reading level of this textbook. Okay? Well, we don't want to find the reading level of every single sentence in here. It would also be difficult to say number every single sentence in this entire textbook and then randomly select, 20 sentences. What would that be? What would that be an example of if I numbered all the sentences and I just randomly selected some sentences? Okay, good. That'd be simple random sample. So what might be easier is to cluster sentences into pages. What if each one of these pages represents a cluster, and then I do a random number generator from 1 to 597, and I generate a number, boom, and then I open up to that page, and then here's the key, and here's how it's different than stratifying. Then I picked my cluster, and I do every single sentence on that page and get the average. Do you see how in this stratified random sample, I grouped them, and then I randomly selected from those groups? But here with clustering, typically your clusters are smaller segments. Okay, so cluster into smaller segments. Then survey all in that cluster. Okay, so that's how cluster sampling is different. It's difficult, but imperative, meaning you have to do it. You have to get straight the difference between this simple random sampling and clustering, okay? And the homework you're going to do, several of them, especially like number 11, is going to give you different examples to hopefully clarify that, okay? Another example, like if we clustered into our first periods, maybe here at Aledo High School, we clustered into our first periods, and then I randomly selected a first period. Let's say I selected Miss Sam's first period. How would I sample her first period? Would I randomly pick people out of her first period, or would I survey everybody in her first period? Survey everybody in her first period. Okay, that's how you cluster sample. Okay, all right, systematic sampling, it's really easy. Number everyone. And then pick, here's an example. Pick every 100th student. Okay? So put them all in alphabetical order. The whole entire school. Put them all in alphabetical order. Boom, 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 boom. Your number 100's in my sample. Da, 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 da. Number 200's in my sample, and so on. So by the time I'm done, I have 15 people dispersed. I don't know what their characteristics are, but that would be a purely random way of doing that. That's called systematic. Okay. Good? All right. There is also one more in your book called Multistage Sampling, and that would be a combination of these. Okay? An example of that might be stratify into elementary schools, Coder, Vandegrift, McCall, and Stewart, and then cluster, pick a class out of all those elementary schools and survey everyone in that class. So pick an elementary school, say Coder, and then you pick one of the clusters at Coder, which would be classes. And then who would I sample in that if I was doing a cluster? I would do every single person in that cluster that I picked. Okay, good. All right. Ways to sample badly. This should actually be the word sample, because we're talking about samples here. Okay. These are ways to have a bad sample. And I think one of the most key points that you have got to get from this chapter is that if you have a bad sample, just throw it out. If you have a biased, bad sample, nothing you could do could fix it. For example, okay, remember our bear hunt lab? We're going along, we're collecting data. What was underrepresented in our bear hunt lab? The brown bears, okay? So should I, as a park ranger, go create this elaborate scheme of food chain information about my wildlife preserve? No, because I collected an invalid, poor, visually biased sample. So I don't need to go do my write-up to the, Texas Ranger Commissioner, I don't know, Walker Texas Ranger or whatever, Okay, so because it's based on biased results. All right, so here's some ways that could be bad. Voluntary response sample. This would be send a survey. Here's an example. Send a survey to everyone. and only ones who took the time and the effort, who wanted to, responded. Okay? Then what has happened is your sample is a voluntary response sample. It's those who volunteered. What could be potentially wrong with that? What? What? Okay, all dedicated people. Okay. You know, this is awesome because I'm personally experiencing something like this. At my church, we're debating on changing the times up of the worship service in order to give the Sunday school time people that's in the middle of the two services more time because they're crammed and they don't have enough time. And I think that's very valid and that's good. So they had done just this general survey, but all the people that responded, there was 182 out of 450 regular churchgoers that responded. So, you know, you might be thinking, hey, that's pretty good representation. But what's the deal about all those people that responded? Were they happy and just fine and so they didn't respond? That's what I did, unfortunately. I was happy. I like my service at 9 o'clock. I'm fine with that. So I didn't respond. But guess what? Who all responded? Yeah, the ones that were unhappy, the ones that wanted change. And that's what we have down here, voluntary response bias. Only the ones that wanted change, that were unhappy, responded. And so those two are tied together. And so you get those two, the voluntary response sample creates that voluntary response bias. Okay. All right, convenient sampling. Here's convenient sampling. I'm sitting outside of Pizza Hut, and guess what? I survey all the people coming out of Pizza Hut and ask them what their favorite pizza is, or favorite brand of pizza is, or their favorite pizza restaurant, okay? I'm sitting outside at Cowboy Stadium, and I survey all the people coming outside of the game who their favorite football team is. Okay, that's convenience sampling, and you're going to then get some bias from that. Okay, so convenience sampling, let's give that example. Which one do you like better, the football? So sit outside. What's the new stadium called? No, it's not Death Star. The Death Star. Is it just, yeah, I thought it was just Cowboy Stadium. Okay. Whereas before, what was it? Texas Stadium, correct. Yes, okay. So sit outside of Cowboy Stadium and ask the football player, or ask the, what are they called, the people that go, the fans, okay. Ask the fans who their favorite football team is. Okay, that's convenient, but biased. Oh, absolutely. Is it used in statistics or in advertising? Absolutely. So, yeah, when you get some results that don't seem right, yeah, exactly. Where'd they get them from? Okay, under coverage, that's going to be, you know, you're not getting enough things. You're not covering enough of the group or enough of the population. For example, let's say I want to know, okay, if we're talking back to Aledo ISD, let's say I ask Mr. Rat's second grade class who what is the best bus route. I don't know. I'm just, you know, so that affects the entire school district, okay, but I only asked just this very limited group, okay? So ask one second grade class, I don't know, their favorite lunch item. How's that? That makes more sense maybe. Okay? Okay, that is not representative of the entire district. All right, that would be under coverage. Okay, now this is about to erase. I'm going to go down here to response bias. Okay, so we talked about voluntary response bias already. Here is our non-response bias. Okay, that would be you send a survey to everybody and then a significant amount of them do not respond. Okay, so you send a survey and a significant amount. There's no number put here. Amount don't respond. Now, I have to tell you what. This is on my list of things to ask that master teacher that I'm going to go see in October, because I do not know if you have to be an expert at telling the difference between this voluntary response bias and non-response bias. Voluntary response bias is a form of non-response, because you're only getting the people sending it in that are unhappy, so these non-responsive people were fine and were happy. They kind of go hand in hand. So to me, I can't really differentiate between the two. And you know what? Sometimes, I mean, we might not have to. I don't know. I'm going to check that out for you. It's on my list. Okay, the last one is poor survey question wording. You could ask a question 2 different ways and get a totally opposite response. We're going to see a video here in a second. It's kind of funny on that. Example from it was this. Let's see if I can remember. The Russians have over 50 million pounds of nuclear arms. Are you in favor or opposed to a freeze on nuclear weapons? Okay, when you state it that way, you would say, hey, let's freeze those nuclear weapons, okay? All right, then you go ask another person and you say, hey, the United States and Russia have, 100 million, between the two of them, have over 100 million pounds of nuclear weapons. Would you support or oppose a freeze on nuclear weapons? And you might think, okay, well, there's, all you did was just add in the fact that we together have a whole lot of nuclear weapons. Then you say, I think we should probably freeze them. Or wait, what am I saying? We should not support, we should oppose a free, I don't know what I'm saying. Okay, but we'll watch, I'm confusing myself. But we'll watch this video and you can see that the way that you word the question, one way to one person, the other can get opposite results. Okay, so you have to be very careful when you do a survey. I'm confusing myself. Okay, but overall, you have to understand this. If you have a poor process, you have a biased sample, then your results are completely useless. I went to an hour-and-a-half meeting Tuesday night about that church survey, and they said they're wanting to do all of this change based on the 182 people that voluntarily responded to the survey. And I'm saying, hold on a second. There's 300 and so people that are happy. Yeah, I did. And so I said, so wait a second. And so now we do the regular old thing. We're going to form a committee and then research it more. I don't know. So maybe one of our projects is going to be to design a correct survey or get a correct sample. Okay.